Hello, this is a video on molarity and how to calculate molarity. By now, you should have watched the video on the overview of concentration terms and maybe even on solutions in general. And as you know, molarity is one type of concentration term. Solubility, molality, mole percent, mole fraction, mass or volume percent are other ones. Molarity is a little different. First of all, molarity you can calculate or have a molarity solution for any saturated or unsaturated solution. As you know, there is nothing else as long as you just add solute to solvent. Unlike solubility, which it's only for saturated solution, molarity, molality, and all the other concentration terms can be used for saturated or unsaturated solutions to make them, that is. So the special thing about molarity, which is big M, is equal to the moles of solute over the volume of solution. And that volume usually is 1 liter. Okay, so the big thing about molarity, all the other ones, as in all the other most common concentration terms, it's the parts that they talk about and not the total. Okay, so therefore they talk about the solute and solvent, and they provide information about that, and then you make the solution. Molarity, what you have is you have the solute, but then you have the whole thing, which is the solution. So therefore you have to be careful on this. They must provide you solution information, specifically solution volume, so that you know what the volume of the solution is. Because the volume of the solvent isn't necessarily the volume of the solution. Because remember, when solute goes in, it goes into the particles of the solute goes into the spaces, the empty space between the solvent particles. And sometimes what happens is those solvent particles kind of expand a little, so the solution's volume isn't the solvent's volume. So that's why when you make the solution for a molarity solution, there's a special thing. What you have to do is you have to use what is called a volumetric flask, and you have to fill the volumetric flask about halfway full of the solvent, add all the solute, dissolve all the solute, and then put the rest of the solvent in to get it up to the solution's volume. You have to dissolve all the solute first, because if you don't and simply just put in the volume of the solution as solvent, you're not going to end up with the solution that is the solution that volume you want. It's going to be more or less depending on the type of solute. So therefore, you have to be careful on how you make molarity solution. That means capital M with the R instead of the L. So how do you actually do molarity calculations? Here's an example of molarity calculation. How many grams of potassium nitrite do I need to weigh out if I want a 250 milliliter solution of a 0.427 big M solution? Okay, if you the assumption is all solvents are water. So when you see a chemical in the question, that's a solute, unless they specifically tell you that the solvent is some other chemical. So you know what the equation is. Big M is equal to moles of solute over liters of solution. In the question, they're looking for how many grams of solute. Well, that equation doesn't have any have any grams of solute in it, but it has moles of solute. So what you do is you solve for the moles of solute using this manipulated equation. Well, you need liters of solution, so you have to change the milliliters into liters, and the molarity is, you can't use the big M. You have to break it up into its subparts because big M doesn't cancel with L. So you break it up into its parts, which is moles of solute over liters of solution. Therefore, being able to cancel the liters of solution, and we find out that we need 0.1067 moles of potassium nitrate. Has one more significant figure than you're going to have in the answer. And therefore, what you're going to do is you're going to then change the moles into grams using your molar mass, which you calculate. Okay, that's using by equation. You can also do it by dimensional analysis. So therefore, you have 250 milliliters. Okay, you have 0.427 molarity, which you break up into moles, and you, as you know, you need the molar mass. So the 250 milliliters you need in liters, so you bring it to liters. And your molarity is your conversion factor from volume to solute information. So therefore, you put the liters solution on the bottom, put the moles of solvent on top. You want to get rid of the moles of solute, and you're going to go to grams of solute, and therefore you get the same exact answer. So for this one, you can do it either way. So either way works. I hope this helps. Thank you.